Hello everyone. So this is a question from JEE Mains 2026, 8 April Shift 2. Given at 298 Kelvin, E naught Fe plus 2 to Fe is x volts and E naught of Fe plus 3 to Fe is y volt. The E naught of Fe plus 3 to Fe plus 2 in volt at 298 Kelvin is, okay. So the chapters involved is electrochemistry. So so when they say that that is E naught of Fe plus 2 to Fe, so E naught is obviously the standard electrode potential, and E naught Fe plus 2 to Fe is for the reduction reaction. So this is for the reduction reaction. How do I know it is reduction? Because Fe plus 2 is getting converted into Fe, so it is definitely gaining electrons. So this E naught Fe plus 2 to Fe is for the reduction reaction. Fe plus 2 gaining 2 electrons to form Fe, right? So let's say that this is reaction 1, and for this reaction they have given the E naught value, E naught cell value, that is x volt. Okay, cool. Then they have given us one more thing. Can you see? They have given us the E naught value of Fe plus 3 to Fe, which is having y volt. So they have given us that E naught of Fe plus 3 to Fe, the standard electrode potential. So this is for the reduction reaction. So again, you can see Fe plus 3 is becoming Fe. This is possible only when it gains electron, right? So this E naught is given for the reaction Fe plus 3 gains 3 electron to form Fe, right? And let us say this is reaction 2, and for this reaction the cell potential is given to us, that is y volt, right? And they are asking us the E naught value for this reaction, that is Fe plus 3 getting converted to Fe plus 2. Okay, so our aim, so we are supposed to find E naught for the reaction, that is Fe plus 3 is gaining 1 electron to give us Fe plus 2. So we are supposed to find the E naught for this reaction. So let us say this is our aim reaction, okay, and we are supposed to find out how many volts are involved in this particular cell reaction. Okay, so can you see, to get this reaction, if we subtract 1 from 2, okay, remember this is reaction 1, this is reaction 2, so subtract 1 from 2, that is 2 minus, that is you are supposed to do 2 minus 1. Okay, so if we subtract, to get aim reaction, we subtract 1 from 2. So in that case, what will happen? If you do reaction 2 minus 1, we will get Fe plus 3 electron minus Fe plus 2 minus 2 electron, and in the RHS there will be 0, nothing. So what I'm doing is, so this is the second reaction, so LHS minus this LHS, so Fe plus 3 minus Fe plus 2 minus 2 electron, Fe minus Fe, that will be 0, right? Okay, so upon subtraction we see that, so we will get Fe plus 3, and 3 electron minus 2 electron is basically 1 electron, and Fe plus 2 will go to the RHS and it will become Fe plus 2, right? So clearly you can see that this is our aim reaction. So we can say that our aim reaction is nothing but basically reaction 2 minus reaction 1, right? And it is very tempting to write that the E naught of this aim reaction will be equal to the E naught of second minus E naught of 1, and E naught of 2 is given to us, that is y, and E naught of 1 is given to us, that is x, and therefore the answer will be y minus x. This is incorrect. Okay, this is, JEE Mains is not that easy. Okay, this is incorrect. We cannot do this, as E naught is an intensive quantity. Okay, very, very important. E naught is an intensive quantity. Okay, and by intensive quantity I mean something that depends only on the nature of the substance. In this case it is the cell reaction. It depends upon the nature of the cell reaction, and it is independent of the amount of the substance present. Okay, so it depends on nature of cell reaction and independent of amount of substance present, right? So therefore we cannot do normal algebraic functions, for example addition, subtraction, multiplication, division, with intensive quantities, because they don't depend upon the amount of substance that you have taken. Okay, but extensive properties can be added, subtracted, multiplied, divided, like normal numbers. So therefore we have to think, how can we relate this E naught to an extensive property? Okay, so for that exact purpose we have a equation, that is delta R G naught is equal to minus NF E naught cell. So this is a very famous reaction where delta R G naught is standard gives free energy change, standard free energy change of the reaction, right? The dot stands for standard, delta G is gives free energy change or free energy change, and R stands for the reaction. N is the number of moles of electrons involved in the cell reaction. F is Faraday's constant, 96500 coulombs per mole, and E naught cell we know, right? So in this particular formula this guy is extensive, so therefore we can add, subtract, multiply, divide this guy. Okay, therefore for reaction 1, so reaction 1, if you remember, this is the reaction 1, this is reaction 2, and this is our aim reaction. Okay, so be careful. So for reaction 1, so I will write it down again, that is Fe+2 plus 2 electron is becoming Fe. So for this reaction, obviously x volt is the potential, so we can write delta R G naught of reaction 1 will be equal to minus of, can you see there are 2 electrons involved, so minus 2 into Faraday's constant into x, because the cell potential is given to us, it is x, right? For reaction 2, that is the reaction Fe+3 plus 3 electron is becoming Fe, right? And for this the voltage is given to us, cell potential is y volt. Okay, so therefore again we know the delta R G naught of second reaction will be equal to minus, you can see there are 3 electrons involved, so minus 3 into again Faraday's constant will be F into y, because the voltage is given to us as y, right? And for the aim reaction, that is our aim, so we will write it down again, Fe+3 plus electron is giving us Fe+2, right? So we can again write down delta R G naught of aim is equal to, can you see 1 electron is involved, right? So therefore it will be minus 1 into F into, we don't know the voltage, so let's say alpha. This is what we are supposed to calculate. Okay, this is what we are supposed to find out. So this is the E naught of the aim reaction, right? And if you remember, we just got a relation between aim 2 and first, that is the aim reaction is nothing but reaction 2 minus reaction 1. Okay, so I can write this down, aim reaction is nothing but reaction 2 minus reaction 1, and this time we have a extensive quantity, so therefore I can write delta R G naught of aim reaction will be equal to delta R G naught of reaction 2 minus delta R G naught of reaction 1, because now it is extensive and we can subtract them. Okay, and delta R aim we calculated, that is equal to minus F into alpha, so I will write minus F into alpha equal to delta R G naught 2, we know it is minus 3Fy, and minus of delta R G naught of 1 is minus 2Fx, so I will write minus 2Fx, right? So upon solving, we will get minus F alpha equal to minus 3Fy plus 2Fx. Okay, and divide by minus F both side, minus F minus F. So we will get 1 here. So alpha will be equal to minus and minus will become plus. So 3y again plus and minus will become minus 2x. So therefore the E naught value of the aim reaction. What is the aim reaction? Fe+3 gaining 1 electron to form Fe+2. So therefore the E naught of Fe+3 to Fe+2, right? For this reaction it is 3y minus 2x. So therefore this will be the answer. Okay, thank you.